All right. You left off at slide 16. All right. I got distracted by the better solution to this, which is DevOps, the modern solution, beyond what's in your book. All right. So 16 is here. Okay, good. All right. So anyway, that's Agile, Agile's idea of programming. So what the idea is, one team will carry a project from the start to the end, and therefore you won't have one team undoing another team's work. And so that's Scrum. After Rugby, one team runs all the way from the start to the finish. Extreme programming is pairs working together with constant communication and rules to try to prevent mistakes. Many, many techniques are out there. And then there's Spiral, where you go around developing, testing, measuring, refining, and then you have more development and testing and just endless cycle, which is more or less the way it is. So in my Windows, you have an endless chain of updates coming out. So it looks sort of like this. You plan the next phases, progress through the steps, test everything, do risk analysis, and then make a new plan. And then go through all the stages again, and then make a new plan, and on you go. And if you have something like ISO 27000 compliance, then your entire organization is just a loop like this, where you're constantly improving. And there's rapid application development is a technique to supposedly make it quicker. And then there's prototyping, where you make little prototypes. This is, you know, I teach people terrible Python programming from the book Violent Python, which real programmers get mad at, because you just make sleazy code, you don't handle the errors, you just get the job done as fast as possible. And we used to call this, you know, hacking, but the dignified euphemism is rapid prototyping, making sleazy code without worrying about the details. And, you know, 90% of a programmer's real job is all the details. But a hacker is an attacker. They just need it to work once. And it doesn't matter if it doesn't handle the exceptions as long as it works once. So it's rewarding. And this is another case. That's prototyping, making a mock-up of something, not the finished version. So this is Microsoft's software development lifecycle. It includes security in every phase. And there's also a National Institute of Standards document about it, specifying it. So you initiate a project, you have development and acquisition of parts, and then you implement it in operation and then disposal. You have all these steps, and you should start with the security plan right at the beginning. So you prepare a security plan, then you initiate it and define what you need, and then you have develop and acquire things, implement things, and install controls, and have security tests. And then you have an operation and maintenance phase where you have to do things like patches and updates. And you have to audit and monitor it to see how well it's working. And eventually you have disposal at the end, where you have to archive the parts you need to preserve for later, and you have to sanitize the media so you don't leave extra data around. So I got these integrated product teams. And there's also software escrow. There's a lot of these things. I wonder how often this really happens, but supposedly you can get like the source code and put it in escrow because it's still proprietary, but in case the company goes broke and vanishes, you can get the source code from them and then adopt it as your own product. I think one of the fundamental problems here is that companies die really fast, and you're left with hardware and software built by some team and you can't maintain it anymore. That's why I know there's a law that was passed a couple of years ago that you are allowed to hack into something legally and reverse engineer it if the original company no longer exists. There's also issues like the open source people are always trying to push government agencies into using open source projects instead of Microsoft products because they can audit the source code. And under some circumstances, Microsoft has even let government agencies have their source code so they can audit it to pass those requirements, with the agreement that they're not going to leak it into the public. Microsoft has also begun putting some of their source public on GitHub. Like they joined, they decided to have Windows containers because Linux containers are so cool, and they joined Docker, and they agreed to publicly post their code in Docker. So Microsoft is embracing a lot of the procedures of the open source community more and more.
Yeah, it's really surprising. I remember going to, you know, Linux user meetings and it's just seemed a picture when NetWare allowed an agreement between Microsoft and them, and it was just pandemonium. It was such ridiculous partisanship.
there was such a war between the open source and Microsoft, and basically they've ended up compromising. You know, the open source systems now have all these fancy desktops with all the graphic junk on them, just like Microsoft, imitating Windows. The difference between the two is diminishing, and the hatred is diminishing.
The position where technology is first, not partisan, you know, soldiers.
Yep, yep. Well, I think it's a natural instinct of people to form camps and fight.
Yeah, I think so too.
Yeah.
I agree. It's a tribalism anyway.
Yeah, yeah. You feel safe because you're in your herd, and you know you're in your herd because you complain about the other herd and point out some difference you can understand. It's an instinct. It's not doing us a lot of good, but it's an instinct. So then you have your code repository somewhere. Especially if you do DevOps, you need to have strict version control. You need to have a central repository that everybody can reach. So everybody needs the right version of everything. So you have to contain something like GitHub. There's also the newest one seems to be GitLab. People like better than GitHub. And on it goes. One problem is a lot of developers put passwords and keys and secrets in the source code. And once you start sticking the source code in repositories, you shouldn't be doing that anymore. You never should have done it anyway, but people are waking up to this problem. And I think a month ago, GitHub said they now are automatically scanning every submission for things that look like AWS keys. And they will notify you or block them, which is a good idea because there were like thousands of projects with public credentials you can search for them in GitHub and find them. So the APIs are the application program interface. This is a series of calls you make available to outsiders, like the whole world. So a Facebook is the king of this. Facebook is like an operating system. It's not that people actually use Facebook. Facebook is a platform, and people put software on it, like games and stuff. And they want that, like Windows. Windows, it's not that people want what Windows does. They want the apps that run on Windows. Windows is a thing that developers use to write the apps, and Facebook does this. So they have an open API where you can make requests for Facebook, and that's why everybody can do login with Facebook. There's an API where you can send a request that says, please authenticate this person and tell me who they are. And then it tells you who they are, and you say, okay, now I know who you are, and I did not have to handle your password and store it or anything. I just let Facebook do all that for me. And this is useful as long as you read the documentation, use the API. This is how you make your product into a service that other people can use. And this is a good idea if you want to be integrated into a big web of business partners and sort of informal developers that contribute things to you, like Mozilla has all these extensions they didn't write, and so does Burp. And Facebook has all this stuff that people added to the platform. The problem is the APIs can be insecure, and there might be exploits that come in through the API. So you should realize that anything coming in from there is not to be trusted. So there's a lot of API toolkits, and here's issues that OWASP talks about. They give you some code you can use for authentication and access control and cryptography and encoding and escaping input and error handling and all these issues. There are recommended software procedures to do all these things. And if you don't have someone guide you, you're very likely to do some of these things wrong. And so once you have software of some kind, now you have a series of changes and configuration, and there's a configuration management plan and control board and change control and monitoring, all these things to keep track of what version you're using and when you're going to change it and what the changes are going to do. And so DevOps, the old system had a strict separation, one team into another team, and they had different skills. And one of the many pain points is that the IT team is always overloaded, so people either circumvent them and start putting up their own Amazon machines without proper controls, and they're not integrated into the network and not secure, or everything is delayed as you wait for your backlogged IT team to do it. But DevOps is the more agile solution where everybody should know how to do enough IT to do their job, and they should be automating their job. That book explains the Phoenix Project. So I got some cahoots, and there's more after this. So this is chapter 8. I think this is the first cahoots in chapter 8. So let's see. Oh, it's going to be chapter 9A. Good, okay. And I have to fix the sound because of that lunchtime presentation. I was sending the sound out the wrong adapter. There we go. have 6 Hooters. We have grown. All right, so which computer code is the closest to English? Of course, source code. All right. What method uses the same team for all steps of a project? That's Scrum. I think it is a term from rugby. Which method uses prototypes and dummy GUIs? Yeah, rapid application development. What's GitHub? Code repository, now owned by Microsoft. Robert, PC, and B are the winners, and we're up to here, I think. So it's, I'll just put it here, we'll mix them together. Robert, PC, and B. All right, and that's going to be 628. And this should just vanish. There. All right. So, all right, so databases. A big deal. I used to be a DBA, so this is familiar territory for me. If you haven't worked with databases, most people find them a little confusing at first. So you have, it's a structured collection of data that is more complicated than just a table with one row and one column. It's a bunch of tables which are connected together. The typical case is transactions and orders. Transactions and customers. You have a list of customers, and each customer may have many transactions, so there's a one-to-many relationship. And so you can do queries that search through the database for something, and you can insert data and delete data. And database management systems control all this, and they enforce security and consistency in the database. So database administrator is the person who has the authority to change the structure of the database and the contents of it, and you send commands in a query language. Usually it is SQL, structured query language. There are other languages, but that's by far the most popular. And so now there are attacks. You can infer high privilege data from the low privilege data. For example, like we said before, back in the days of Centrex, you would have a special phone number of high privileges, and you could go through all the phone numbers that are used for normal calls and figure out that the high privilege one must be one of the other ones. And there's aggregation attacks where you combine many low privilege records together to deduce something about a high privilege record. These are problems. So here's the main types of databases. By far the most common is relational, that is the normal database. The rest of these are special cases, not that used that often. So relational database is the standard thing here. I have a whole SQL injection tutorial, several in this way. So you have a table of users and a table of social security numbers. Here they just have a one-to-one relationship. So these could be collapsed into just one table in this case. But anyway, that's what you have. So their tables have rows and columns, and they have a primary key field that uniquely identifies records almost always. It's not required, but almost nothing works very well until you have one. So you have something like a social security number or a customer ID that uniquely determines who you're talking about. And you can have a foreign key in another table that connects to the key in this table. In this one, I'm just using the name as a primary key, which is a poor practice in general because two people could have the same name. But for this small data set, it works. So this is the primary key of the users table, and this is a foreign key over here for the same data repeated just to associate the social security number with it. All right, and you can join those tables. That's a mathematical relationship between them, so they are aware of the fact that this key maps to that key, and this record should connect to that record. So if you go to something like Facebook and look at your profile, it has your name and your picture, and then your posts and your address and stuff, and it's fetching all those from different tables. matching them to your customer ID, and accumulating all the data in one page. So referential integrity is making sure that the keys match, that you don't have a record with no key, and you don't have two records in the same table with the same primary key. The key has to be unique. Semantic integrity makes sure that the field values are the right type. You don't have letters in a numerical field or punctuation marks in a money field or things like that. And then that's integrity, making sure that you don't have empty primary keys. Everything has to have a non-empty, unique primary key. So here's the data table lacking integrity. It has a duplicate primary key, that's a violation, and it has something here that is not a number of days, but something else in that. That should not be allowed. That should be forced to be just a number of days. That's the sort of thing. This is what happens if you let people type data in and you don't check it for accuracy on the way in. You end up with junk in your database. The most common problem I see, like retailers, is they have some form that is poorly designed and it asks the cashier to type in things that they don't know or that they can't easily find out, and they have to fill it in with junk to get it to go through. And this is how you're wasting everybody's time. Then later on, when you try to use that field, it's all full of junk. This is a huge problem of poor database design. There's a thing called database normalization where you remove all redundant data. If you, I don't know if this still happens, you used to get like 3 or 4 copies of catalogs in the mail because people bought mailing lists and there's duplicate lines, and for some reason there was some minor difference, so they didn't realize it was the same thing. And if you have multiple places where the same information is stored, you can eventually end up with inconsistent records. Like if you have the name in one table, and have a name in another table, then the customer gets married and changes their name and calls up, and the representative changes the name in one table, it might not get changed in the other table, and now you don't even know what that person's name is. So normalization is the process of cleaning up your database so nothing is stored more than once. There is one place where any data is stored. And there's a series of normal forms here, first, second, or third normal form, where you clean this up. So there are database views that show you the information in the database in a particular way that is convenient, and this is what cash registers are, and this is what your profile page is in Facebook. It shows you the information from the database presented so you can see everything you need to about just one customer at a time, or just one transaction at a time. There are data dictionaries that describe the tables. This is the metadata. This is database structure, also called the database schema. That describes the types of data that are stored, the names of all the columns and fields, and the relationships between the tables. And so here's a database schema showing that I have an employee table with 3 attributes, and here's what they are: digits, string, and so on. That's all it is. Defines the structure of the data that's going to be stored here. So there's data definition language and a data manipulation language. SQL is the most common query language. And there's MySQL is the open source public one. Microsoft has their Microsoft SQL. There's other ones out there from Oracle, and everybody has their version of SQL. They all work pretty much the same, but the detailed syntax is a little different, and some of the exotic commands work a little differently. So yeah, they all have these basic functions: create a table, delete a table or a record, select a record, insert a record, or update a record. Those are things you can do. So typical command you see is select star from employee where title equals detective. This will select all the information, that's what star means, from the table named employees, where that condition is true, where the title field equals detective. Now there are hierarchical databases, which are a different kind of structure like DNS, where you're trying to look up www.google.com, so you look up www from Google server, and you look Google server to find that way. And you do it this way: you start at dot. If you don't know anything, you ask them where the .coms are. You go to the, tells you where you can find out the .coms. This tells you where you can find out about Google.com, and Google.com tells you which particular IP address points to www. That's a hierarchical database with this kind of structure. And the DNS system is a distributed database. It's a bunch of data you can look up, and the data is distributed all through these servers. There's no one server that has the whole DNS database. There has been a movement. The United States has made a lot of trouble with DNS. A few years ago, the French government allowed file sharing. So the person in France would download a copyrighted MP3 from a French server, and it would be a copyrighted American movie, and that is legal in France. And the US government said that we want to prosecute those French citizens because the DNS resolution involved sending network traffic back to America to resolve the domain. And therefore, they did pass through U.S. jurisdiction and are eligible to U.S. law, which means the entire world, the entire internet is subject to U.S. law. And that was perceived by the Europeans as enormous, outrageous overreach. And there was a big angry movement to stop using this DNS system and make their own. And some people have talked about how it really should be a blockchain and not this data structure, but they didn't get enough people interested to do it. Like I say, there's a whole bunch of European privacy and other concerns that are really worried about all the American stuff they use. And they scream and yell to say we should just use European stuff, but there is no European stuff that gives you the same value for the same money. So they all mostly shut up and just put up with the problems of using American stuff for the convenience. But it just sort of died away and they kept going. You know, they didn't actually get to arrest people in France. I mean, it's just, this is like, you know, yelling at Russia and stuff. I mean, they weren't going to start a war over it. And, you know, I think people just forgot about it. Yeah.
How does the DNS work for parsing? I mean,
well, that's another huge issue. I think domain names, well, I guess there can be in Unicode. That's a good question. I know that the extensions at the end, I don't think there are any other foreign languages. The part in the middle can be. I know Chinese domain names can be in Chinese. And if you look at them in English, they're XN or something. There is some kind of encoding where the part of the domain name can be in a foreign language. And somehow it maps back. But I wouldn't be surprised if a lot of it is like ultimately fundamentally English. And it's a good question. I should ask somebody I know that speaks Arabic or Chinese or something to explain that to me. The extension at the end, it seems to me like the only possible extensions are like .com and .net. There isn't one that's like .Chinese stuff. So it's got to be kind of a constant insult to the Chinese people, right? They have to type in English stuff to get to domains, even if it's a totally Chinese name. I don't think they really can be an option. Yeah. That's a very good question. I don't know the answer. If anybody does, let me know. Anyway, then there's object-oriented databases that have object-oriented programming. So they have data structures, objects that contain code and values, and they have inherited structures and all that jazz. You can have database integrity. So if the database management system attempts to perform an update, it will decide that that update is not allowed for some reason. For example, someone else is updating the same record already, or that update is forbidden because it violates one of the integrity rules, like it changes the primary key to null or to a duplicate value, and then it rolls back from that update and it fails. This is sort of like network traffic you send and you get an ICMP 13 back saying undeliverable because there's no entry in the routing table. You make an attempt and it rolls back, it does not happen. There is a journal that logs all the transactions. This is very important to handle problems like this, especially when something crashes and you've sent some changes and you don't know if they went through. Then you're going to be glad you had a journal. So if you have a single database on a single server, life is really easy. But then, of course, if that server crashes, you're hosed. So that's not good enough. So high availability databases have to have multiple servers working together. And therefore, they have multiple copies of the table. And now you have an issue of how you keep them synchronized. In traditional databases, relational databases, all copies of the database must always be synchronized all the time. So every update in one table has to go to all the others. Now, that's what banks do, and that makes sense. But Facebook didn't want to do this. Facebook said, well, you have servers all over the world, people putting updates all over the world. And if somebody posts a Facebook post in Taiwan, I don't really need everyone on Earth to update right away. It's okay if that update sort of percolates and takes maybe 5 minutes to make it to America. Nobody would really care. So they tried to go to a NoSQL database called Cassandra that would allow these imperfect, slow, percolating updates so the various copies are not identical for their use case. And they thought they would save a ton of processing power and everything by doing this. And that we were the real champion of NoSQL databases, which were real fashionable. And from what I understand, they pretty much decided this really isn't as great as you thought. It didn't really save as much and it made everything really confusing and they pretty much gave up. Until like 3 years ago, a lot of people were pushing these NoSQL databases, sort of like they were all pushing blockchains. And in both cases, everyone pretty much said this is sort of a waste of time. This doesn't really have a benefit, and it just makes everything really confusing. Anyway,
So
yeah.
what are they doing? They're doing multiple copies of tables everywhere, or are they doing live replication database?
I don't really know exactly what Facebook's doing now. I do know that a lot of people switched to NoSQL databases, and a bunch of them gave up and switched back.
So most people do
Relational databases.
and no, sorry, maybe I asked.
Yeah.
If you have a relational database,
Yeah.
do you just copy all the tables to the backup and the commands of the relationship also, so it then does it somewhere else, or do you do the whole database first?
Well, if you wanted to back it up, you'd back up the whole thing. But while it's running, if you have multiple servers all over the place to serve everybody, then every update has to go to every copy.
Okay.
Yeah. Every transaction is duplicated every copy. So they're all synchronized. This started in the financial sector, where if I have a credit card and I go to China and run my credit card, the local copy of the table has to know my exact balance. It's not okay that I already spent that money, but it will take time before it finds out because I did that in New York. They synchronize everything all the time. And all attempts to save that effort have pretty much turned out not to be worth it. It's worth making that effort to just make sure all the copies are accurate all the time. Because as you can imagine, if you have many updates coming and you don't really reconcile them all in real time, what a mess you're going to have when multiple contradictory updates reach your intermediate nodes. Anyway, all right, so here's the database replication mirrors a live database. That's what I'm describing. Original and copy are in use. You could also have a live backup where it is making a copy of the transactions and everything, but it is not used to process customer data. It's just there to make a backup. Hey there.
Hi, can I interrupt for a minute?
Yeah, for the survey I
Coastline College has a little swag for you guys.
Oh, even better.
They're these cool little battery pack things, and
Oh, good. Those things are
I
good.
thought it would be easier for me to get them
Oh,
to
yeah.
you today rather
Sure.
than try to catch you as you're walking in tomorrow.
Sure, and we have to do surveys, right?
Yes, please do the surveys, and then I'll give you a wrap up. We've got some super cool stuff.
Do you have the URL for the survey? Did you already email it out or what?
Oh, yeah.
Oh, okay.
Those kinds of things.
I should put it on my website.
And then Sam, tomorrow when you're done, please bring this down.
The signature sheet? Oh, sure, yeah. Good.
Thank you.
Yeah, thank you. Let's see if I can find the survey link. I'll put it on my website if I can find it.
It was just something from me. So just look at
Okay.
my-
All right.
It was I sent a little notice out about parking, and that was also it was parking and
Let's try parking. I might do it.
there it is.
Current standard. Well, parking and survey. Good, good. Survey link. Oh, good.
There you go.
There's the survey link. I will put this on my page, so you people do not have to find it if you don't want to do what I just did. I'm going to put it right here. CISSP prep right there. Okay. Send that up and see how that looks. Okay. So there's the survey. Let's see if it works. All right, good. Okay. I don't know about that. I think probably not. It gives you the certificate, but I don't think it gives you your applicant. Yeah. Anyway, good. There's the survey. That's important. So you can get your little certificate. So you get your money back from your administration or whatever. All right. Fair enough. So that's a shadow database. And then there's data warehouses where you just have a large data case like the federal government has in Utah, where they're archiving all the internet traffic. And once you have a huge amount of database, like the whole internet or something, then you have data mining, where people are hunting through there to find problems or anything else they want to find. All right. So object-oriented programming is programs that are not just a series of routines and a main routine. It's a series of objects interrelated like a map, and relationships like parent and child between the objects. So it's written using the same kind of languages like Java and Ruby, but the code is little routines that are attached to an object, and the objects are connected to other objects. So it's a sort of like a mixture between a database and a code. Anyway, so now you have encapsulation where you can move an entire object around from a single name, and the object includes both data and methods. So you've got objects, methods, you've got messages that communicate between objects, you've got inheritance for one object. You can have another object that includes an instance of a previous object, so it inherits information. And you have delegation, where a procedure that one object cannot handle is delegated to a different kind of object to handle it. And polymorphism and polyinstantiation, I'll have a picture of that coming up. So here's an example of a method. So you have this thing called addy, which is an object that can add things. So when you send it two numbers, it adds them and puts out the output. And then you've got delegation. So I got addy and subby. And so addy cannot do subtraction. So when addy gets 7 minus 4, instead of just returning error, it delegates it to subby, which does the job. And here you've got polymorphism, where data comes in of one type and comes out of another type. Addy can do both strings and numbers. So it takes from the type of the input, it has a different result. Here's polyinstantiation, where you have multiple records for the same primary key with different clearance levels. So a person who gives a number with a top secret clearance level will get one answer. The person that comes from the secret clearance level will get a different answer. And the point of this is you cannot determine a pattern in the secret primary keys and deduce that other primary keys are used for top secret. The same primary keys are used for both. This is a way to prevent you from deducing information about the top secret by examining the secret data. So there were object request brokers, which are middleware that connect programs to others. There are quite a few of these. CORBA is one of them. Microsoft's COM and DCOM are others. These are middleware projects that connect one type of system to another, typically a dissimilar one. Microsoft's component object model, this, by the way, is very interesting. It comes up in the malware analysis course. This is the genius and idiocy of the DCOM model. This is what happened and explains fundamentally why Windows has so many security problems. In the original, Microsoft is like Facebook, is a platform for people to make money. And they really want developers to make money. It's intended to help you run a business and sell things and make money. So suppose you, back in the days of MS-DOS, you write code that runs on one machine, a single processor machine, and you write a subroutine that does something cool in that environment. It's working fine. Microsoft makes it easy for you to take that subroutine and publish it widely. So you take a subroutine that originally ran inside a single process with trusted input. You can now share it on the same machine as a service to all the other programs on that machine. On a modern operating system, it's multiprocessor. So now all kinds of other processes on the same machine are using it. And then you can connect it to a network socket and share it over the internet to everybody. And it is the same code that was written 20 years ago by a developer who was thinking about it just being used in the context of one process. And this is why you have the situation that the Microsoft network shared things tend to be incredibly insecure over and over. SMB, RPC, and all their processors, because they typically are code that was written by developers in a completely different environment who never intended it to be over the internet. This is things like Telnet. Telnet was originally supposed to be one piece of twisted wire connecting my keyboard to my computer, not a network at all. And that's why I could just send characters one by one and it was fine. And then they ported it to TCP/IP to go over the internet, where it is manifestly unsafe. And the DCOM model is intended to help you do code reuse and help you take your code and share it in a wider environment and use everybody else's shared code so we can all make features faster and faster. But it is intrinsically tempting you to have security disasters, because just like moving to the cloud, you take your stuff from your nice controlled playground and you put it in the wild, open, where everybody can get to it. And the people that do this often do not understand that they're moving from a low-risk environment to a high-risk environment, and they really should be auditing it and strengthening it before exposing it to the wild world. Because otherwise, almost all the major attacks have used the same Microsoft flaws over and over and over. Mostly SMB and now also RPC. Like Eternal Blue that killed everything through 2017. For 20 years, it's been SMB, Microsoft for file sharing, over and over and over and over. Anyway, so this is the game, but you can write in any language you want, and you can take your module and share it with other programs and with other computers in the Microsoft system. That's the component object model. It is a brilliant thing to make it easier for you to find software to buy and for people who write software to sell it. So you can build anything and buy a huge marketplace of components to patch together, but security tends to be lost in this process.
The brokers also, that's where most of the hackers want to sit, because it's the right, it's not the man in the middle attack, but very similar to that, because they basically are talking from one language to another.
I don't know. I haven't heard of that, but it certainly could happen. I know there's a product called ActiveMQ, which is an Apache product that connects one computer system to another physically. And it was a talk I refereed at DEF CON years ago where they said this thing is insecure, and I scanned the internet for it, and I found one in Texas that was being used to print checks, that I'd see these checks go by with no authentication at all, and I could change the records with no authentication at all, and I couldn't find the customer. It took me like weeks to figure it out. All I have is a few letters to name. I finally found them. They were a medical insurance company in Canada, and they were printing their checks in Texas, and they had no password at all protecting the middleware, which is publicly exposed to the internet. And I reached them and said, you should really protect this. And while they were taking time fixing it, I researched it more, and I actually found the forum posts from 5 years before where the developer that set up this system was on forum saying, I can't figure out how to do the password protection. Can somebody explain it to me? And nobody did, and they never did. And they just used it for years that way.
You could do a check to yourself.
Yes. Yes. Yes.
I've just seen a lot. I like reading code stuff, but there is no security.
Yep.
In either this or CORBA.
Yeah, and
It's a bomb waiting to happen.
yes, and this is a fundamental problem with code reuse, where you take code that was written in one environment and you use it in another environment, which is probably a different risk factor. But of course, code reuse saves everybody time and money, and it could be more secure. If you wrote good code, you could keep using more copies of the good code. But what typically happens is you have generations of programmers, and as we know, there's just traditions. The whole industry does a stupid thing, and it's not until 10 years later you really realize you better knock that off. And so typically any code that's old is usually insecure. So it's an issue. Anyway, so CORBA is an open source framework competing with Microsoft's proprietary one, where objects communicate via interface description language. And you've got object-oriented analysis and object-oriented design that tries to figure out how to fix problems with object-oriented solutions. So you might have a network intrusion detection system you want to make. So you have a network down here, you put on a network cap, you have the packets go up to the sniffer object. Now you send them over to the analysis object, which will look at the PCAPs and decide whether they are these kind of attacks, and then it will go on to the alerting object and take whatever the appropriate action is for all these alerts. And that's in a block diagram. This is what a product like Suricata does. It's sniffing the traffic and sending out alerts over the network to warn people in various ways about what it detects. All right, and we'll be using it very soon. So this, I guess, is the B cahoots. Which would be somewhere around here. There, 9B. That's not the right, what's going on there? Okay. Trying to get me to pay you or something. Let's see. Cahoots. Favorites. 9B, perhaps I hit the wrong button. Okay, good. Okay. Right, so what kind of database uses joins to connect the tables? Those are relational databases, the most common type. What process removes redundant data? That's normalization, good. What concept is also called data hiding? That's encapsulation. All right, which one is open source and vendor neutral? CORBA, all the rest are Microsoft products. Good. All right. Jane, Coast, and PC. So Jane, PC, and Coast. All right. Fair enough. All right. So back to here, we got the last section. All right. So you have to assess the effectiveness of your model. There's a lot of bugs in software. The industry standard typically is like 15 errors per 1,000 lines of code. Red Hat Linux had a test where they had like 0.15 error per 1,000 lines of code. They were much, much better than average. And that's back when the open source community was real proud of how their code was superior. But in the end result of security, it doesn't actually seem to be much superior. Ever since Heartbleed, the bloom is off the rose. And people who are so proud of Linux have pretty much gone in the corner to cry, and they haven't come out yet. And Linux is not apparently actually more secure than Windows in practice, despite the fact that certain parts of it appear to be more perfect and controlled. The end result does not seem to actually be any more secure. Yeah, that's right. And they thought that the fact that people were more motivated and it was an effort of love would matter more. There were a whole lot of reasons why Linux was better that they bragged about for years. But the last couple of big security disasters kind of shamed them into admitting that the end result is not that different. Yep. Of course, to be fair, until 2002, Microsoft's official policy was to not give a damn about security. So at that time, it probably was true that Linux was more secure because Microsoft was not even trying. And when they decided to try, I'm sure it took them at least 5 years to get good at it. So realistically, it's only been about the last 10 years that they've been comparable in security. But now Microsoft is the product of 15 years of really dedicated attempt to improve their security. And Linux has pretty much stayed the same, and they've ended up about the same place. Yeah, they had such an attitude. And you know, Cisco people often have this attitude about Windows administrators. The same kind of thing, that they're the smart people and Linux and Windows people are stupid. And hackers typically have this attitude about managers. We know everything, and managers are just stupid. And you know, I've held many of these positions and come to realize they're wrong. You know, it's not that simple to be the manager. It's not that easy to put together all these difficult decisions and deal with all these troublesome people that don't do what you tell them to do. And you know, like being a parent, it's not, you know, it's easy to criticize. It's a lot harder to do than you think it is. Yeah. Anyway, so here's typical vulnerabilities. Hard-coded credentials, people put in built-in passwords and keys. Buffer overflows are where you reserve space and then you put too much data in there. SQL injection, we talked about, where the interface between two systems permits a signal to be sent which is misunderstood at the next stage. Path traversal, where a file name can be referred to an unexpected path and you allow that. Yeah, go ahead.
I said, today even so many students will say, oh, I know how to code, but they don't know even the full main vulnerability, so they will not take care of it. And they say,
yeah.
Code. And like,
no, this is a huge problem. Well, no, actually, and I fault the education system largely. I mean, you can get a degree in programming and get an A and do what they told you to do, and you didn't learn anything about security. And at my college, the programming department has no security classes, and the teachers have no interest in security. When I talk to them, they say that's a whole other field. So, and Dan Kaminsky, who's the luminary of this business, they asked him, and he said, you know, there's no point telling developers to learn security because it really is a whole big topic, and they already have another topic. what you should do is build a development environment for them to use that automatically puts the security in, and that is what Microsoft did. When Microsoft figured out that their code was vulnerable and they were getting hacked, they developed special C libraries, which they then released, which removed like the 10 most dangerous C functions and strengthened the others and changed a lot of environment variables to remove most of the problems to address these. And they also trained their programming staff, but it was mainly that they changed their environment so that the worst mistakes were no longer possible. And that's where Dan Kaminsky, and I think he rightly said, that's what you need to do, because programmers are struggling to make it fast and make it work and make it pretty, and expecting them to know the giant amount of security information at the same time is just not practical.
But simple things like user input, validation of user input.
Well,
those are really easy things. I teach a basic class.
Yeah. Well, your position, by the way, I must say, is shared by Netflix. Netflix is famous for being very secure. As a matter of fact, Netflix has the Chaos Monkey. Have you guys know the Chaos Monkey? Well, let me put it up. This is another thing you should see. This is bloody awesome.
I want to see this.
Amazon has one too. Okay, if you're at Netflix, they use this thing, the Chaos Monkey. And what this thing does is it deliberately breaks everything. Servers turn off, network connections go down, data is corrupted in transit, data that is stored gets corrupted. They deliberately wrote software that breaks everything frequently. And the idea, they say, what, are you out of your mind? They say, no, we tell everyone, don't program by assuming that things will be okay. Assume that nothing can be trusted. So if you have a server, you better have two servers. You better have some plan to deal with what if data comes in, what if that data is wrong? If you load data from disk, what if that is wrong? And to enforce it, they run software to deliberately break stuff all the time. So nobody gets complacent. And they say the end result is their stuff stays up. Netflix, the servers crash and the power fails and the software has bugs. Netflix sails right through it because all their stuff is resilient. That's right. Amazon does it too. You can't build, and so the Netflix guy came and talked to us at my college. I said, can we send you some interns? And he said, no, I don't want your interns. I don't want your graduates, because there is no programming class in the world and no certificate in the world that teaches people to write secure code. We don't even look at anybody unless they have 5 years of industry experience coding, because it's only on the job that anybody learns to write secure code. And we don't want anybody here that's going to write crap. So never mind. And that was an interesting lesson. And Facebook came to our college and said they wanted to prototype their code path coding, secure coding class at our college. And my department chair brought a lawyer and sued them to drive them away because they're insane at my college. But I tried to sneak them in. Their only thought is, whenever they were partnering with anybody, they say, oh, they're going to steal our students. And I said, because their idea is to have a prison where you trap the students in to keep enrollment up. I have a different theory where you could actually teach a good class so people come to take it, and they don't believe in that theory. But anyway, yes, they sued CodePath to make them leave, to not come and teach a secure coding class. We could have been the prototype secure coding academy, and they drove them away because the thought of partnering with Facebook, they saw as they're going to steal our students. I'm like, you idiots. Our students could be getting jobs at Facebook. We could have the #1 training center getting jobs at Facebook. What part of this is hard for you to understand? How do you see this as a negative thing? What the hell? They said, oh no, this class they're proposing overlaps with a lot of your class. They'll steal our students. I said, no, that is not what's going to happen. How stupid can you be? We'll have a great program and people will come to take it. Who cares if it's better than what I'm teaching? You should teach the best thing. And then people will come, but they didn't go for that. Anyway, so I'm off teaching other places. Anyway, but anyway, this is pretty cool, and Netflix is pretty cool, and I thought that was pretty good. If you have a good, and now CodePath does have secure coding classes elsewhere, and they're trying to develop a secure coding development, a secure coding program, and there is some movement towards that. So it is. But currently, it's high employment for all of us. Everybody has to hire a coding team, and then they have to hire a security team to undo their work. So it doesn't seem very logical, but that's where we are.
Then it's designed that software don't literally, I'm consolidation,
Yep.
and then separation between a black box and the client. You
Yeah.
have to understand basic knowledge, which most of them don't want to understand.
Yes, I think so. And if your coders don't know it, then you have to have another team putting it in. Somebody has to know that. Anyway, so those are the big flaws in software vulnerability. So buffer overflows are where you reserve space, but then you put in more. Time of check, time of use are race conditions, where you save something and then you read it later and it changes in between. This happens all the time. You can win the race. There's a bunch of famous examples of this. Many privilege escalation exploits work this way on Linux systems, because you go to one of those SUID binaries that elevates briefly and you find a way to make something else happen while it's elevated. Cross-site scripting is a very common problem. You have a place where a user can inject something, and like a name that they'll paste on the wall, and you let them inject script. So now they add script to the page that runs in someone else's browser. The main consequence of cross-site scripting is that one user can hurt another user, but they cannot usually hack into the servers, so companies don't feel motivated to fix it. So like 80% of all websites have cross-site scripting vulnerabilities. It is considered a low importance finding, and people won't pay for it in bug bounties, and they usually won't fix it. But it can be used to be devastating, because you can write JavaScript that steals cookies from the user's browser so you can get in their session. But it happens all the time. And Beef is a tooling collie, because I don't get that much fun out of it anymore, but it used to be pretty cool. Beef alters HTTP on the wire to add script. And that's why browsers will now warn you if you load any page over HTTP. Even if it's just a static page with no login or anything, just loading the page over HTTP means that anybody could have added code to it on the way to you, and you would never know, because HTTP is just best effort delivery, unencrypted, no certificate, no nothing. So I could just pick it up with a router and modify it and send you a modified page, and you have no way to know that hadn't happened. And it's easy enough to do, and Beef can do it in a nice automated GUI-based way. So you just add code to it, and now I can run JavaScript in your browser at will when you're just opening pages. So I can use your browser as a bot. Now I can only do what your browser can do, but browsers can do a lot, especially if you find a vulnerability. You can often move from the browser and take over the OS, and then I can do anything. But even in the browser, I can do quite a lot. Cross-site request forgery is where I take a credential from one environment and move it to another. The most common form is to steal a cookie. I can steal your cookie and then replay it from another machine, and now I get in your account, unless the developer remembered to put in anti-CSRF defenses. There should have been a second parameter, like a hidden field in the form on that machine that won't be on the next one that loads the form, or they should have taken your IP address and encoded it into the cookie or something like that, so that when I take the same cookie to another machine, it won't be accepted, but almost nobody bothers with that. So this technique is pretty devastating. And there are many other versions of it. Ways where you take an authenticated session and you somehow trick another machine into executing something which is interpreted as part of the previous authenticated session. Privilege escalation is escalating from a limited user to administrator or root. This turns out to be extremely easy. Unless your kernel has been updated in the last 3 months, you almost always have one of these vulnerabilities. In Linux and in Windows, they never seem to fix them at all. Metasploit has a bunch of modules I've been using for like 10 years that just keep working. It's ridiculous. You just type get system into an interpreter session, and it just works on every version of Linux. And it only does like 5 or 6 common tricks. Microsoft never seems to fix them. It's very strange. Horizontal escalation is getting into another user's account, and once you are root, that is usually pretty easy to do. There are backdoors. The FBI wants a backdoor into everything. They want to be able to come with a court order and get it. Most companies put backdoors into their own stuff, but if you do, you'd have to somehow stop other people from coming in through your backdoor. So it should be something. Cisco has 8 times this year had to remove backdoors from their stuff that are just locally stored passwords. They apparently still have developers doing the really old school. If you watch the movie Tron, his son gets into the server because he knows that his dad always puts a backdoor in, and it's always like backdoor and the password is backdoor or something. And he tells his son, I do that for everything, so he knows how to get in everything. That was the old system. You just have a magic word that you knew, and Cisco is still doing that. They're just beginning to emerge from that culture. Apple had a much more subtle backdoor in the phones until about 5 years ago, where you had to send the phone to Apple, where they would boot it up with special stuff that was only on premises that could get in to something like single user mode. So they could get in every phone, but there was no tool outside Apple that could do it. And that's what they could do. And that's why the FBI screamed bloody murder when they turned that off. And they said, what was wrong with that? That was fine. The customers were fine. The criminals couldn't get in, but the FBI could get in when they had a proper court order. And then they turned that off, and the FBI was frustrated. So they paid for the Israelis to just hack in totally. Now they can get in entirely. So, you know, that's Apple thought they were increasing security, but obviously that was not true. In fact, there was obviously a mistake that was more open than that anyway. And all they did was create a market so that exploit would sell for $1 million. If that's law enforcement with a way to get in, they wouldn't have paid $1 million to the Israelis to get that exploit. So you created the opposite of your goal by trying to demand too much. Anyway, there's often backdoors in systems either put in by the developer or put in by a hacker. And if it's a hacker, it's typically a rootkit, but it could be a lot of things. And so once you find a vulnerability as a security researcher, then you have the issue of disclosure, which we talked about quite a bit. Who do you tell? Do you tell anybody? Do you just dump it publicly on a blog? Do you tell the company and try to get money out of them? Do you tell some other party, like sell the exploit through an exploit broker to a government agency, which is usually the NSA? These are all options. And anyway, that's the game. That the traditional behavior recommended in the security community is responsible disclosure, a term Microsoft made up that people mostly sneer at. But this is where you tell the vendor and give them time to patch it. The problem is the vendors always want forever. You tell them and they would like you to wait 10 years and just shut up.
Bug bounty programs, whatever works?
No, well, they sort of work. Bug bounty programs are no good for a security researcher. They are a boon to people in third world countries who are desperate for money. Bug bounty programs, if you just put one up without careful planning, it accomplishes nothing, except you get a lot of spam email and a lot of reports about things you don't understand. You have to work with a company like BugCrowd. They'll help you do this. They'll plan your program and administer it and help you understand, and they'll even like vet the reports for you. So you get reports. You have to have a team ready to respond to them, and you have to understand what you're going to get. You're going to get a lot of reports, all from pretty much Pakistan and India. People that live off these bug bounties, and what they do is they learn one particular attack and then they try every company possible to get some money out of it. So you'll get many reports of the same thing, and only the first one gets paid and all the rest will be really mad at you for not taking it. And a bunch of them will be communicated very poorly, so you can't understand them. So this happened to Facebook. Facebook had a bug bounty program, and some guy found a vulnerability in Facebook where he could do something like alter the number in a cookie and get into somebody's account. So he sent an email to Facebook, and they didn't fix it. So he sent another angry email to Facebook, and they didn't fix it. So he hacked Mark Zuckerberg's wall and put a post on his account. And that got their attention. And then they actually figured it out and fixed it. And then he demanded his bug bounty. And they said, you violated the terms of the bug bounty. You're not allowed to go on someone else's account. And he screamed bloody murder at me. These rotten bums, they're unfair. And then it all became public. And they showed the email that he wrote. And I would have done the same thing. I couldn't understand a single thing. It was just angry, misspelled, disrespectful garbage. Blah, blah, blah. You idiots, you don't know anything. You're stupid stuff. You didn't understand that from code I can't understand. And blah. And like, I couldn't understand a goddamn thing. I'm sure Facebook couldn't either. They just threw it away. The next one was more of the same. Then they hacked Zuck, and Zuck says, what? But, I mean, that's the problem. I don't really blame Facebook. You have to actually communicate in some terms that someone can understand it if you want a bug bounty. And so most researchers, when bug bounties came out, all the security researchers jumped on, this will be great. And they mostly found this is really, really disgusting. You have to work really hard, and then almost always you're not the first one, so you don't get anything. And even when you find something great, 90% of the time they tell you, oh, that's not in scope, that doesn't really count, we don't really care about that. So I sent a bunch of them about DNS locking records. See, I learned, New York Times got hacked about 8 years ago by the Syrian Electronic Army. Now, the Syrian Electronic Army at this time was one 17-year-old in Syria, loyal to Assad. And his only hacking skill was social engineering. He could write emails and convince people that he was somebody he wasn't. So he contacted DNS registrars. He contacted the New York Times DNS registrar and said, I am the system administrator at the New York Times, and we are moving our server to this different IP address, and they bought it, moved the New York Times to a different IP address where he put up like propaganda about Assad instead. And so for a day, the New York Times was down. And it took them a while to figure out what happened and reversed it. And there is a process called DNS locking. You can tell your registrar to lock my record, never change it unless you have a really highly verified proof of identity. You can do that, and people don't know that. So I read blogs about it, I learned how to do it, and I notified a bunch of companies, your record is not locked, and it should be locked. And they totally ignored me. And then like 3 years later, they paid me like $300. Hey, actually, that was pretty interesting. They marked it educational. I said, well, I guess that's my thing. It was not, we weren't even thinking about that. So they didn't pay me right away. But years later, they decided I deserved money for that. It's like, you have to be doing whatever's fashionable at the time. They're only going to pay for getting reports of what they expect. And usually you will find something that's not on their map until you do a lot of it, and then you learn, get in the groove, and you learn how to do it. And so you can make a real living at it, especially if you're only looking for a small amount of money, like someone from a country where a little bit of American money goes a long way. It can really be a miracle in your life. You can have like $50 or $1,000 a year or something from nothing after you learn how to play the game right. But it's not at all a replacement for a good security team, your internal audits. It's of less value than people imagine. But now it's very accepted because the Department of Defense did it twice. I was in the first one. I had to get approval. Then I got into the Department of Defense. Then I found out everything is running on Windows Server on .NET Nuke. I said, .NET Nuke? It still exists, and the U.S. Army uses it, and it was all full of vulnerabilities. I didn't find them, but other people found 100 vulnerabilities. I was sort of unable to figure out what to do with that. But anyway, now people are getting over thinking bug bounty programs are crazy. But in fact, most companies aren't really ready for them. You have to have a relatively secure, relatively advanced security program to be ready to handle a bunch of reports intelligently. So, but it is a good step. It's a good step in your maturity process to reach a point where you could have a bug bounty program. Anyway, so there's a capability maturity model from Carnegie Mellon. This is their framework for creating quality software.
This has been around since 2005.
Oh, sure. Well, God knows if they work. I mean, Microsoft has one they've been doing since 2001. Some people swear by them, other people swear at them.
I know that people create.
I don't know. This is the problem with this whole field. We have all these security procedures, and the end result is more people get hacked every year. So you could argue that everything I'm telling you is all garbage. It's just the only thing we have. We appear to be losing this war. The hackers are getting further, more criminals, more data breaches, more records lost every year. And so far, the only thing we know is to train more people in what passes for the current. It's like we're dying of the Black Plague, so we train more astrologers to like more accurately save people. It's all we can do. It seems like understanding security would be helpful. It doesn't appear to be doing us much good in practice, but it's all we've got. Anyway, so here's the 5 levels of the Carnegie Mellon system. You have an initial ad hoc and chaotic, where somebody just makes like a rapid prototype or something works, but you haven't even made any attempt to figure out if it's scalable or anything. Then you have project management, so you can at least deploy it on another system. Then you standardize the process. Then you actually manage the code quality. And then you eventually reach optimizing, where you actually define what it's supposed to do, create it, measure how much it does what it's supposed to do and what's wrong with it, and then try to fix the defects and go around the loop so it's constantly improving. Acceptance testing. This board has 4 levels: user acceptance, operational, contract, and compliance. And then there's a attempt to figure out the security impact of software you might purchase. I read a nice blog post from H.D. Moore at Rapid7 about this, because he is a security celebrity. He wrote Metasploit, and he had Rapid7 that got acquired by another company. He's very powerful, and he actually has the ability to audit all purchases of the company. So when they tell him they want to buy like some routers, he will get the router and do a security audit of it before he lets them buy it. And he tells how to audit stuff. He always finds vulnerabilities because he's awesome. And that would be great. Almost nobody has that much power, but it would be nice to actually tell them, don't buy this one, buy that one after testing it. Usually the rest of us They buy all this junk, and then a year later when they get hacked, they tell us to secure it. We didn't really have a chance to stop them from sailing down into this dark place in the first place. And home users buying IoT things are just filling their house with time bombs, and they don't know any better. But yeah.
I tell this story about cuts. I used
Yeah.
to do RFPs. But LA City put out an RFP because they had bought open software and then they had bought primary Microsoft. So what was data coming out of the SIS? They were then taking this, printing it out,
Yeah.
and then putting it in hand
Yeah.
on the other thing. Now they wanted a cut off the shelf that would talk to two of them,
Yeah.
and they don't want to pay for anything more.
You know, the same thing happened to the British nuclear submarines. The British nuclear submarines upgraded to Windows 2000 as the giant leap forward, because before that, they had a computer system at one end of the subroutine that would print a piece of paper so they didn't have to carry to the other end of the subroutine and type into the system here. And by upgrading to Windows 2000, they were able to network them together. So anyway, this kind of thing tends to happen. So anyway, when you buy things, you've got to actually check things. Vendor claims are usually highly inflated. And the problem is vendors will go out of business, and vendors might stop adding support and updates, and then you're hosed if you're building this stuff into your system. And you might be able to get service level agreements with companies, but of course those won't last if they get acquired or go broke, which they do all the time. So in many ways, our whole reliance on other people is contrary to the real world. I mean, there's a time when people will get a job at Kodak and they work for 30 years and retire, and that was their whole career. But now everybody jumps ship every 2 years typically, and the companies vanish underneath them too. And so what good is a deal with a company? They'll be gone pretty soon. And then, of course, AI. By the way, Courtney Brown told me that he would teach an AI course here if we asked for it. So when you do the survey, you might want to ask for that. I think that would be awesome. He can teach an AI course at this level, at this event, so we can add AI classes to our curriculum. It's not that hard. He knows how to write them, Python libraries. It's not mind-boggling stuff, and it's everywhere. We really should all be learning AI and teaching our students AI, and he knows how to do it. I don't, but he does.
And then think that we should be getting an AI.
I've seen blog posts about how these days you can just write a few lines of Python and use a library and then just give it a training set and a testing set, and you can do AI without having to do anything too difficult or mind-boggling, at least in simple cases.
Or you have to know Python.
Yeah, but not super advanced Python or anything, just simple Python. Just import a library, use some calls. Yeah, there are libraries out there. It is not advanced coding. It's elementary coding, stuff that we could reasonably expect to do and for our students to do. And AI is now the hotness everywhere. Everybody's building AI and everything. We really need to start getting our students on board with it. I want to take that course. I want to add it to mine. I don't know anything about AI, but I'm interested in learning. I did learn how expert systems worked. I read a good blog about it, and I was very interested because I used to be a research scientist years ago, and it's exactly what I did. All you do is you get some data. The data has a trend. Then you make a model, like a linear model, a polynomial model, an exponential model, and you optimize the parameters until you're getting most of the variation, and then you call that a solution. That's all I used to do. I recognize this process. Humans did it. This was called scientific research. I remember doing it. And if that's all it is, that's really not that hard to imagine automating at all. And that's what AIs do if they're going to learn to control a power plant. They have sensors, like 100 sensors sensing temperature and pressure and stuff. And then they have some output of whether they're winning or not, like the overall, is it going to overheat or not? And so you let it have various exploration of the inputs and exploration of the outputs. And it just has this like 100 dimensional space of all these inputs and then whether I won or lost. So you get all these data points, and then it just forms a mathematical model of what combination of inputs lead to success. And that's AI. That's computer learning. That's one form of it. And that part is really not too hard to understand. You can rate how good it is. You always have to have a learning set, which you have to have a set of data which you split in half to practice on and half to test it with. So you train it on this, and then you run it on that, and you see how much of it wins, and you know how well it learned. And the end result is that's machine learning. Anyway. Yeah.
Years ago.
Yeah. It was my postdoc many years ago, a very early version of this, long ago. I did cellular automata, which were a very primitive thing. I know it grew up. You know, when I did it, it was so far from being worth anything. It was just a curiosity.
Right.
And I said, man, this has to get 1,000,000 times faster before it'll be any good. And that's what happened. It got 1,000,000 times faster.
They call you crazy if you were, what was your thesis? They're like, you're nuts, you should do something else.
Well, yeah. Well, they started with Lisp, and who are you kidding? I mean, that never went anywhere. But it was the early start of something that would eventually get good. And now it's finally gotten good to where it's really going to do things. It really can drive your car, and it rams into people if it's going more than 50 miles an hour. Tesla rammed into somebody, didn't even hit the brakes for anything because it was going over 50. And they said, this is not a failure. It says right in the book that the self-driving thing will ram right into things like people and trees if you're going over 50. And I said, I wouldn't buy that car. How does anybody think this is acceptable? And one of my students came up and said, you should stop bad-mouthing these cars. I bought a Volkswagen that's self-driving, and I understand, and I accept that. That's fine. That's totally reasonable that if you're going over 50, it rams right into things. And I said, that's reasonable to you. That doesn't seem reasonable to me at all. But that's apparently is the way they really are. And I'm like, God damn, I wouldn't let anybody sell a car with a defect like that. That's a defect. It's like the antidepressants. The side effect is you commit suicide. Like, wait a minute, what? How can anybody find that an acceptable side effect? This happened to one of the security researchers on Twitter. She went off to a conference. Her husband killed himself. And she's like, what happened? She found out, oh, it's a known side effect of the medicine he started taking. She said, how could this be a side effect? How could they give people medicine like this? What the hell is going on here? And I agree. I mean, the world has gone insane. But, you know, the last presidential election convinced me of that, too.
Tesla, and I am right on the side. But he likes to self-drive.
Well, if I liked it, too, when I thought it would do a better job. If it rams right into things, I like it a lot less.
Because the new update doesn't actually slows his car down. And he says it's the best thing. He said,
Well, I would love it if it worked.
and you know, he tells me I don't understand.
Well,
Because
my first thought is it would be better than people because I see how rotten people are. But I'm not so sure the current generation is actually better than people.
Some guy was remarking about how two cars will determine what's going to happen on a very dark road at night. Who's supposed to do what? And the guy said, well, finally a reason for the baby on board.
For the what?
Finally a reason for those baby on board.
Oh, that's right. Yeah, there you go.
Try to figure out who's going to go for the side of the mountain.
That's right. That's good. Yeah. Anyway, it's the brave new world coming. We have expert systems. So they've got a knowledge base, which is rules that it uses to make decisions. And they have an inference engine where it follows the tree formed by the knowledge base. So you can have, there's some that work like real brains where they have modules connected to other modules and they change the strength of these connections based on experience. And there's Bayesian filtering where it looks for patterns of things like filtering spam email based on keywords. And as we all know, that is notoriously ineffective and easily circumvented. There are genetic algorithms where you have mutation and some kind of test of quality and you kill off the weak. And you even have ones that have sexual reproduction where they mix the properties of two codes and then they try to imitate all these techniques and somehow refine it. There are many techniques used by this. And as you can imagine, you have to do an incredible amount of calculation to end up in one winning system this way. But that's the brave world. And the main thing is, if you go any security product, every security company, Juniper and everybody, their latest product is AI. It is the new hot word. There's AI in firewalls and everything now. And I don't know how good it is, but it's the new buzzword. You got to have AI or you're nowhere. So that's why we got to learn it. Even if it's no good, we got to learn it. It's everywhere in the marketplace, everywhere on the job market. We better start getting on board with it. Anyway, like maybe I'm just too cynical, but I of course assume that since this is the first generation, it's probably all crap. But I think people have now decided it's worth having a first generation because there will be a second and third generation, and by then it'll probably really be good. And so getting in early, there's probably a real job future, and it'd be good for our students. Anyway. Unless you're, yeah, so don't, that's right. You know, I really wanted to ride a robot controlled taxi. I wanted to get an automatic Uber. And now I'm thinking maybe I'll just wait a while, let somebody else ride the first couple.
You call Johnny Cab? Total Recall movie from
Yeah.
Arnold Schwarzenegger.
Yeah.
He was in Wars.
Yeah.
Economy. The cat was Johnny Cat, and the cat went crazy
Yeah.
because he cursed at it.
Oh,
and
yeah,
then
yeah, yeah.
tried to kill them. And then
Yeah,
exploded.
yeah. Yeah, I know. That's right. Well, I thought it'll be fine. Oh, but computers are reliable. It'll be fine, but I'm not so sure anymore.
It's when your fridge tells you that your son is going to go somewhere
Yeah.
today from Facebook, and you're not scared. You have
Yeah, I know. It's the brave new world. Okay. So which one does PHP have as a flaw? Okay, that's file inclusion. It commonly puts the file name in a parameter, and you can often make it refer to a different file name. What flaw is also called a race condition? Time of check, time of use, where you check for something and then you use it later, and maybe I changed it after you approved it and before you used it, so the actual value you used is not the one that was approved. Which problem is caused by developers leaving test code in a production environment? Yeah, they put in code to the test version and they deploy that code instead of cleaning it up before shipping it out. That's the backdoor. So you have a maintenance hook. You have a special backdoor to get in case it crashes, and then you forget to take that out before you go public. I think this is probably why so many Android apps break HTTPS. They didn't bother to configure their phone to have proxy, so they turned off the certificate validation so they could put a man in the middle to test the code, and then they forgot to turn it back on when they deployed it. That's my theory. I don't really know that, but that would make sense anyway. Which one is the Carnegie Mellon Software Quality Framework? The Capability Maturity Model. Okay. So it's T, PC, and Jane. All right. T, PC, and Jane. Fuck. Wait a minute. Okay. There. All right. And so Robert is clearly the highest. Let's sort them. This is the glorious final scores. You deserve some applause or something. So Robert is the winner and PC second. You're both in the room, I imagine, right? You're Robert? There you are. Good. Who's PC? Oh, great. Well, you guys are appropriately sitting on the right. So good for you. Who's B? Okay, good, good. All right. You're Jane? Okay, well, good. Anyway, so this is good. And so I tried to sort them by chapter. So in case you actually care about the CISSP, you might have some measure of which one to study, but I wouldn't take it too seriously. So I'm going to stop the share and change topics anyway. Now we're only at 2:30, so I think I probably can't send you home right away. But what I think we ought to do is take a 15-minute break, and I'll start you on the Splunk today. And I think you'll find that it's worth just continuing tomorrow. I have a lot of other things we could do, but I would start with Splunk.